In this video, we're going to set up the server to use a vector of TCP connections for all of the client connections. We are going to begin receiving data on the server from the clients, and we are also going to begin detecting if a connection was dropped for the clients. First, let's go to our server header, and let's set up a vector for our connections. Something else we're going to have to do is we're going to have to set up a master file descriptor set for our file descriptors, and it'll contain the file descriptor for the listening socket as well as the file descriptor for all of the connections. Now let's go into our server CPP, and let's first modify this to use our file descriptor set. We're going to move this code where we created the file descriptor for our listening socket file descriptor right on up after we listen. And then here we're just going to add that to our master set. Now if we go back down, what we can do is we can create a temporary vector to use for when we poll, and that way we won't corrupt the master set. The reason I'm doing this is because when we call WSA poll, it's going to be setting these R events members in every single struct. So if we use a temporary vector instead of our master one, then we won't have to go through and reset all of the R events every time. This way, when we call poll, we are just going to pass in the data for our vector, as well as the vector size. Just to make it clear what is going on here, I'm going to create a reference variable for our listening socket file descriptor. We're going to have it set up so that the very first file descriptor inside of our master vector is going to be for the listening socket. Everything after the first element is going to be for the individual connections. I'm going to put in a region to separate the listener code versus the connections code. And that way we can close that and just pay attention to the code that we'll need for our connections. Before we do that though, inside of our listener, we have to make a few changes. So first, we don't want to just close the connection right after we accept it. When we accept a new connection, we want to add it to our connections vector. So we're going to call in place back. We're going to call the TCP connection constructor. And we're just going to pass in these arguments that we had previously for the accepted connection. Next, just to make it clear, I'm going to make a reference variable to access accepted connection. That's just going to be the last connection in our vector since we just placed it back. Next, we have to create the WSA poll FD struct for this connection. For the file descriptor, it's just going to be this connection's socket. We could access this a few ways. We could do the new connection socket since that's what we pass into our TCP connection, or we could access the socket members get handle from our accepted connection reference. It doesn't really matter. Next, we need to set the events that we're going to check for. We're only concerned with receiving data for this scenario, so we're just going to check for poll read norm. Next, we need to clear out the R events because that's what gets set by WSA poll. The last thing we're going to do is we're going to add this file descriptor to our master set. Now we have added our connection to our connections vector, and we have added the file descriptor for this connection to our master set. We are ready to create our for loop to begin receiving data from our connections. So what we're going to do is we're going to make a for loop. And if you notice, we are iterating from 1 to the size of however many file descriptors we have. And remember, the reason that we're starting at 1 instead of 0 is because the very first file descriptor is for our listener. Everything after the first one is for our connections. It's important to keep in mind that the connection index and the file descriptor index will not be the same due to the fact that the listening socket has a file descriptor entry, but it does not have a connection entry since it's not actually a connection. We're going to declare what our connection index here is for referencing. and it will just be I-1, of course. For each connection, we'll need to go through and check if an error occurred on the connection before we try to read data from it. If we look back at the documentation, the errors that we're concerned with are going to be poll error, poll h up, poll inval, and then I don't care about if priority data is ready to be read because we're not using it and because it looks like Winsock doesn't even support it. And I don't care if out-of-band data is ready to be read because we're not using it. What I do care about, however, is if normal data is ready to be read, because we need this flag to be there if we're going to try to receive data on that socket. First, let's implement these 3 errors and handling for them. So we'll say if an error occurred on this socket, we will print out an error message. And before we do that, I'm just going to make a reference to the connection just to make this a little bit cleaner. So we'll just print out poll error occurred on, and then we'll print out the connection info. Next, we're going to go ahead and remove the file descriptor from the master and from the use file descriptor sets. We know the file descriptor's index that we're removing is going to be at index I. Next, we need to close this connection. And then we need to remove this connection from our connections vector. Don't forget that we have a different index for our connection than we do for our file descriptor. So that's why I'm passing in connection index here, and I'm passing in I here. Next thing we're going to do is continue to go to the next iteration of the loop. But since we're iterating from 1 to the total size here, we need to decrement I. Because when we erase a connection, it's going to move everything after it 1 slot up. So we can decrement I here to take care of that. Next, we just need to add in the error checking for the poll hangup and for the poll inval. So poll hangup, we will say if poll hangup occurred. That will work. And then we need to add it for inval, for if they use an invalid socket. Now we're done with the error checking regarding events, so we need to check if normal data can be read on this socket. What we will check for is for poll read norm. For this example, what we're going to do for now is just create a buffer of max packet size. And then we're going to try to read however many bytes there are into this buffer and print out how many bytes we get. This is only going to be temporary. We're going to create an integer to store the bytes received, and then we are going to call receive. Now the first argument for receive is the handle, which we can get that a couple ways, but the shortest way is by looking at the file descriptor and just the FD member for that. Next is the pointer for the buffer for where to put the data. Next is the max number of bytes that we could be receiving here. And lastly, we have the flags, which we're not doing any flags, so we'll just put 0. Now you may be wondering why I'm not using the socket receive function that we have. There's a couple of reasons, but the main reason is because in socket receive, if we get socket error, it implies that the socket was closed. However, when we're using non-blocking sockets, it's very possible that you can get a socket error and the socket has not been closed. And we will cover that in just a moment. Next, let's take a look at the bytes received. If the bytes received is 0, that means that the connection was lost. So I'm just going to copy our code for closing a connection. Say connection lost. And then we will close the connection and continue. If the bytes received is socket error, then what we need to do is we need to check what that socket error was before we close the connection. What could happen is a connection could have the event that normal data is ready to be read. However, normal data may not really be readable without blocking. If we get the last error, and we check if the error was that it would block, then we can determine if we need to close the connection or not. And what we'll do is we'll say, get the last error if the error was not that this would block. So if it was an actual real error that we're concerned with, then we'll close the connection. However, it's very possible that we could go to read data and then Winsock says, hey, we're not ready to read on this socket yet without blocking, which we don't want to block. Then in that case, we are not going to close the connection just because it would block. We're just going to go on to the next iteration and pull it again. And one more thing is just going to add in a little more detail for when we close due to a error that occurs when we try to receive, and just have the return value for receive. The last condition that can occur is that we actually do receive some type of data. And if we do receive some type of data, we're just going to print out what the message size is. And there we go. I believe our server should be set up now to accept multiple connections and detect when they're lost, and also print out the size of the messages we get from them. However, there's one thing I need to change on the client. That was just a mistake. Was after we connect on the client, we need to set this is connected member to true, because in our source code for the client, the loop's only going while is connected is true, but I was never explicitly setting that. Another thing is, back in the server source code, when we call initialize, we should clear out all of our file descriptors set. They should be clear. I don't know why you would call initialize twice on a server, but just in case they're not, we're going to clear out the file descriptor set as well as the connections. Now let's save this and test it, see what we get. Alright, so you see we're attempting to send chunk of data, and we are getting the data. Now, we could always open a second client now as well. And you see the server, the way we can differentiate between these two clients, since they share the same IP, is by looking at the port that is being used. One's using 64303, one's using 64307. And then, of course, when one of them disconnects, we get the poll error occurred on, and we get the port and the IP. And then when the other one disconnects, we get its IP and port. So already we're able to handle multiple connections and receive data from multiple connections. However, we aren't really able to process the data. If you remember from our blocking series, we were able to just get the packet size, fill in a packet, and then pass it into our process packet function. But the problem is we're not really able to get the packet data with our current setup. That concludes this video, and in the next video, what we are going to do is work on adjusting our server code to be able to fill in packets that we receive into our packet class, and to be able to call the process packet function from our current server setup.